myself some new grow lights, gone very budget. It came with a pack of 4 of these and some 3M sticky tabs, sticking them up. They're basically just an array of LEDs on a aluminium backed board, so that's the heat sink. So I was a little bit worried about the temperatures of this and whether it's going to be okay up against the place in the grow shelf where I'm going to be sticking them. So I had to check the temperatures and have a look at that. Now the problem is I just want these to be turned on and off with a normal sort of power controller, and it came with a much fancier setup than I thought. The first confusing thing is this is USB-C, except it isn't really. It's definitely not USB-C, but it uses a USB-C connector, and that's sort of weird. Now the controller does a few things on and off. As you can see, that's now very bright. And then it's got some dimness settings. And I checked this with the multimeter, and it basically just seems to be adjusting the voltage. It could be just the multimeter reading a PWM value, some sort of average, I guess. But it doesn't really matter because I only ever want this to be at its brightest setting, where it's basically supplying it the 12 volts. This thing is plugged into a 12 volt transformer. So that's pretty much just feeding the 12 volts straight through at its brightest setting. And this has all kinds of fancy things. It's got, you can sort of have just those lights or just those lights, or all of them. And I only ever want all of them. This is just a grow shelf. It doesn't need all this finicky stuff. Now the problem is that it doesn't actually come back on after it's powered off. So if I unplug the power from this device like that, and then plug it back in again, it's off. So I won't be able to control this by switching the power supply on and off with a power controller. See, what we use here for a lot of things is these TP-Link power controllers, which interface to our sort of other home automation stuff and into home assistant, things like that. So that's how we turn the lights on and off for the shelf, where we've got the other big grow light in there already. So I basically need to modify these. And to do that, I'm going to basically wire 12 volts straight into it. I've got a couple of different potential 12 volt power supplies, like this sort of thing. I've got much smaller ones, but I'll probably use one of these bigger ones. I've also got this one here. So we've got plenty of 12 volt power supplies around the place. And we'll just basically set this up to run straight off 12 volt. I won't use the original one it came with. I was looking at taking off these little USB-C connectors because they're pointless. And this thing just strikes me as kind of dangerous because it's actually not putting out a USB power sort of correct power signal. It's just feeding 12 volt into one place and wiring the other two looped down to ground. To basically, it brings it to ground to turn on either that set of lights or that set of lights, or both of them for all the lights. And that whole thing can just sort of get in the sea, really. So what we're going to do is we're going to wire this straight into 12 volt. And I've done it a couple of times. I've been fiddling with these. So that works there. It looks pretty ugly, I know. I was originally hoping I could sort of wire into the pins, but the problem with the pins is that if you look at here's one. You look at this. The way this works is it does provide 12 volt to the correct VCC pin, which is this one here. This is just a little USB-C power only connector, pretty much. So it's got 12 volt coming in there, say, and this one here supplies one side, and that one there supplies the other set. So that's the sort of A lights, and that's the B lights. Now, I was hoping I could just wire straight into these contacts, but it's actually just a bit finicky down there, and I don't really want to bother doing that. So what I've done with that one that I showed you before is I scraped off the contacts, and you can see I've scraped off some there as well, but I decided to go somewhere else. So what we'll do is we'll scrape off the contacts in a couple of different places to get that wired up properly, and we'll get a close-up on doing that in a moment. And then I basically just solder a twin wire onto it, and that will run off to the 12 volt power supply. Nice and simple. And then we basically have that 12 volt power supply being turned on and off by our smart switch, and we're good to go. So yeah, let's have a look at that. Now I've got a couple of different ways of getting these connectors off. Strictly, I don't need to get them off. Strictly, I could pretty much just leave it there and get to those tracks in there by scraping a bit of that paint off. But the USB-C connectors also just kind of annoy me. It annoys me that they're there. So I'm just trashing that. So I tried getting it off with the soldering iron and the wick, which only did so far. And as you might have seen on one of those other ones with the wire, I made a pretty bad mess of getting that off because it pulled up track and all sorts. And I think the actual connector also had a bit of glue underneath it. So what I've done instead is I've wicked off what I can, and then I brought in the heat gun, and that's actually managed to pull that one off on that one relatively neatly. So that's not too bad. Right, so let's strip off the USB-C connectors on this one, and we'll see how we go. So this is just getting off the excess solder, getting it into that wicking braid. Cool. What I do to get some downward pressure on that is I actually plug it into a USB connector that it came with, which I'm not too fussed about damaging. I pop on a little bit of this masking tape just to protect that from the heat as best I can. And then we get the heat gun out. Yeah, nice and easy. So that's off now. A little bit of burning, a little bit of funny smells in the room. Probably should have a extractor fan of some sort. Looks a bit messy, but we can clean that up. First thing we'll do is we'll just dab a little bit of extra flux onto there. Just pull up any excess solder off those contacts. Cool. And then we have a bit of good old isopropyl. Just did a bit of tissue. A little bit of a sponge. Wipe that off. Get the tissue onto there. Yeah. Most of that manky looking stuff was pretty much just the flux. So we're looking pretty good there now. And doesn't that look a lot better than the other one I did? Okay. So I don't know how well you can see those tracks, but this one here is the positive supply. It actually goes underneath that 0 ohm resistor to bridge everything across there. And then the ground supply, the ground side for the A LEDs is this track here of those two contacts, which have delaminated a bit. And then for the B lights, it's this track here. What we're actually going to do is we're going to scrape off a bit of that paint there and there and bridge those together, and then get to the positive side up the side there. Okay, so that's our two grounds for our A and our B. Now we'll choose to use a little bit up here to get to the positive side. Just next to me on the bench, I've got my bench power supply, which is set to 12 volts constant voltage. So it's basically the same as the power supplies I'll be using. We apply the positive side to that little contact I scraped off there, and then to this one, the negative, we get some light. There we go. Cool. Blinding. So that's the A side, and then this little one here is the B side. So what we're going to do is we're just going to solder some wire onto there to connect them together. Just put a little bit more insulation off that side. There we go. Just going to tin these. pop a bit of flux onto the board and tin those contacts I cleared up. Got a bit overwhelmed with the flux there. There we are. Not the prettiest thing in the world, but it will do. Now these little silvery clear wires do have an indicator on them to tell me which is which. There's little white tick marks on. So I've made the white tick marks the negative side. Now what we can do to test this is just pull the wire there and work out where I've hidden my power supply leads. Here they are. Try not to contact them together because I've left them turned on. So that's the positive side there. Right, so get the negative on, and there we go. We're all fully lit up at 12 volts. Cool, that's that. No more silly USB connector, and we can wire this straight into a 12 volt supply. Perfect. One final thing I'm doing before I put these up is dab a bit of hot glue around the cable. Just works as a bit of a strain relief. I don't know how well this hot glue will work on this surface that is actually going to get relatively warm due to all the LEDs, but I don't actually think it's going to get hot enough to affect the glue. It's not the prettiest, but hopefully it's effective. So one of the concerns about how we're supplying electricity to these panels is that we may be overdriving it and driving it in some way different to the original supposedly 12 volt supply. So what I've got here right now is I've got one connected to this 12 volt supply and another connected to the original supply because I left one of those USB-C connectors on there. It's sandwiched between a couple of sheets of this corkboard at the moment. And if we pull out the infrared camera, we can see that we've got some warmth under those boards. Now this isn't a natural condition for them because obviously it won't be sandwiched on both sides. So what we're going to do, and this is going to go very bright for a moment, is we're going to record the temperatures of those boards, of those LED panels, as we remove this, so we get some idea of that heat in there. Okay, that's about 60 degrees in the middle of the panels. I think that's fairly acceptable. The big question will be whether the 3M tape that they provided to put them on is actually going to handle that temperature. Though it shouldn't be that hot, it should actually be lower when it's just one side. So the other question is, are the two panels driven differently? And at the moment, based upon this display, it looks like the right-hand side, which is powered by the original charger, is slightly warmer than the left-hand side powered by my 12 volt supply. So we actually might be driving it a little bit lower, which is probably a slightly good thing. To the human eye, they look pretty much the same. So I think that'll be okay. I thought I'd also just quickly test the temperature underneath them. Yeah, and again, it's slightly hotter on the side driven by the original supply, cooler on the side driven by my 12 volt supply. I think we'll be okay. I've also got the LUX meter, so we'll have a look at how much light it appears to be putting out. I wasn't entirely sure what the best way to test the brightness of these panels would be, so I've invented the cake tin luminosity test. Basically, I've stuck my light meter inside that little cake tin there. I've turned off the light that was up above, so it's a little bit darker. This is the one with my 12 volt supply on it. And I don't know if you're going to be able to read that display there, but I am reading 29.0 kilolux on that right now. And now I'm switching it over to the one with the original power supply plugged in. I'm measuring 29.8, 29.9. Do we have a 30? Oh, we have a 30. 30 kilolux. So we're getting slightly more brightness out of the one driven with the original power supply, but only a little bit. I mean, okay, we're up to 31 being read right now. As a curiosity, we'll switch it back to this one, another test point. Coming in at 29.1. Yeah, I mean, that seems to be fairly stable there. So we do have a stable difference of about 1 to 2 kilolux. So yeah, it's only a few percent. I think I'm able to live with that. Otherwise, I'd have to possibly work out a way to ramp up the power supply to this, which I don't really want to have to worry about doing. This is the thing that I call the plant shelf. I built this a couple of years ago for overwintering things and getting seedlings going early in the season. This lives in the study, which is the only room we generally heat during winter in the house, so it's the best place for such a thing. It has this fairly powerful central Mars hydro grow light in it, which generates quite a lot of light and also quite a lot of heat. It does have a lower density of LEDs per square centimeter than these cheap panels, but I have a feeling the class and effectiveness of the LEDs will be lesser on the cheap panels, so I'm not expecting them to be significantly brighter or anything. So what we're going to do is these are going to be stuck to the top up there, and again over that side, and we'll just stick them on with the 3M pads they came with, see if that lasts. If it doesn't, they do have little holes in the corners, and I can just bung some screws in, and that'll definitely hold them. Right, so let's get them up and get them wired in. So that's the 12-volt power supply wired up now. I twisted those wires together, tripled them over, tinned them, and banged a couple of those little spade crimps on there to make it easy to detach. We've got the same spade crimps on at the mains power end, and I did actually use a slightly too tight crimp on that, but it seems to be fine. Obviously, this is a mains power device, and that's just single insulated cable there. So this whole thing should be inside a project box of some sort, with only the double insulated cable coming outside the box, and this should all be protected. That has been put in a box now, just to keep it relatively safe. This is actually a reused box from some other project that has a fan fitted, but I'm not going to plug that in because I don't really think it needs it. We'll get the lid on that, and we're good to go. At some point, I might even get a proper grommet for the 12-volt side. Whilst we're at it, I thought I'd have a quick look at the Mars Hydro grow light we have. It's a much more professional piece of equipment, this. It's got a nice metal case. I've just undone this bit here because what I need to do is I actually want to feed this power cable through the top of my plant shelf. So I'm going to have to disconnect this. I'm just all working out how to do that. What I'm probably going to do is actually just cut these individual wires and crimp them together. I think that's going to be easiest. Vargo's crimps, something like that. For the mains powered proper grow light, I've chosen to put the Vargo connectors in here to make future disassembly easier. I've replaced that strain relief cable tie, and that's now neatly going through the ceiling of the grow shelf. And there we have it. That's all wired in relatively neatly now. We can say, let there be light. Ouch. As for the light levels, using this meter right in the middle, we're getting about 17.5 to 18 kilolux. If we move it out to the sides underneath the position where the new lighting is, which isn't turned on at the moment, we get about 4.2 kilolux on that side. And if we put it sort of near the middle of these ones here, 4.8 kilolux. If we turn on our new panels, we're getting 7.3 kilolux in that same position there, and in approximately the same position over here, 7.3 kilolux as well. In the middle, we're reading a little bit higher because of the light thrown out from those new ones on the side, I guess. We've got 18.9 kilolux in the middle now. And then finally, just for an extra comparison, this has our big grow light turned off, and just the new side lights turned on, and we're only getting 1.6 kilolux in the middle here. Underneath this grow light, pretty much directly underneath, we only get 2.6 kilolux. And over here, 2.5 kilolux. So these really don't weigh up to the power of the big Mars Hydro. So that's interesting to note. But we are getting some extra. I think one difference that could be made with using the sides here would be to increase the height and put some smaller plants in there, say, to get a bit more of that light coming down. A measurement I almost forgot to get was the ambient light in this spot without the plant lights turned on. So this is just in this room with a desk lamp on off to our left and the main room light on at full brightness. So this is what it would normally be during the day probably. And we've got 30 lux. So as you can see, those plant lights really do make a lot of difference to the amount of light in this area. So the big question is, of course, is this all worthwhile? And for me, I think it is. If you're going to try to grow chilies with an early start in the year, then the extra light really helps, especially if you don't have a very particularly sunny window or limited window space. And this will be warmer as well as relatively bright. And bear in mind, say we're about there, we're getting low 30s in the kilolux, and sunlight pretty much ranges from the 30s through to 100,000. So we're not like super crazy daylight bright here. We're just relatively brighter than we would be if it was normal indoor lighting. Now the other question is whether the extra lights I've put in are worthwhile. So we're only sort of reading those 7, 8k lux down here. But of course, you have to bear in mind that as we go up here to where the top of this chili plant is, we would not be getting much light normally from the big central grow light. But up at this height, we're actually getting over 10 kilolux from those lights I installed today. So actually, that's a good result. We are getting decent light into the tops of these overwintering chilies here. And I think that is going to be worthwhile for the extra effort and cost of those lights. I think in an ideal world, I'd have something bigger and stronger, but then that would cost more in terms of both electricity and the cost of the lights themselves. This whole setup is using about 145 watts, and say we ran it for 12 hours a day, that would be maybe 1.8 kilowatts, which would cost us about 55 to 60p per day on our current electricity rates. Considering that this is also the primary lighting in this room now, I think that that's not too bad. It's basically a daylight bulb for our study, where we spend most of our time during the day anyway. As a sort of conclusion, here are all the lux values I measured earlier, taken from down on that surface. Now, this is not intended as a review of these lights or a fair comparison of the lights to each other. Obviously, this is a bigger and more professional style of unit, and it's designed to project down quite a lot of light. And these are much more rudimentary equipment. I got them both from Amazon. They have some weird names as usual. That's a GERYLOVE. This is less weird. This is a Mars Hydro unit, and I'll link to them. Now, I would recommend the Mars Hydro. It's definitely a pretty good piece of equipment, and it's not caused us any problems, and it's been used for a couple of years. These I've only just got, and obviously I modified them and played around, and I'm not really sure that's something I could recommend in and of itself unless that is something you would like to do. I am pretty happy with the final result here. I think it's going to do well. I would recommend that you need this sort of space vertically for this massive light. If it's too close to things, it will be a bit too much. And these probably would actually be better off closer to the plants, but that's why it works with these taller plants. So that works out pretty well in the end. And I'm looking forward to getting 2025's chilies growing, and in this space right here.